In number 9, we have b squared minus 9b over b plus 3 divided by b squared minus 6b minus 27. Now we want to remember that this is really over 1. So when we flip it, the first fraction will stay the same, b squared minus 9b over b plus 3. And then we'll turn it to multiplication, and we'll have 1 over b squared minus 6b. Now we want to try to factor just like we were doing in the last problems. So for b squared minus 9b, since there's only two terms, we just want to pull out a b, and we have a b minus 9 left over. That's still over b plus 3. And for the second one, we need a factor with two parentheses and find two numbers that multiply to negative 27 and add to negative 6. So 9 and 3 multiply to 27, and we'll need a negative 9 and a positive 3 to add to negative 6. Then we can see what we can cancel. So since there's a b minus 9 on the numerator and a b minus 9 in the denominator, we can cancel that. We see that we have two b plus 3's, but they're both in the denominator, so we can't cancel them. So our final answer will be b over b plus 3 times b plus 3. In number 10, we are subtracting. We have 4 over m plus 2 minus 3m over m minus 3. When you subtract or add fractions, we need to make sure that they have the same denominator before we do anything. So to get them to have the same denominator, I'm going to multiply the first fraction by m minus 3 over m minus 3. And I'm going to multiply the second fraction, that's a minus sign, not a plus sign. There we go. By m plus 2 over m plus 2. Then we'll have the same denominator. Our common denominator will become m minus 3 times m plus 2. So now if I multiply the numerators together, I want to make sure that I distribute the 4. So I have 4m minus 12 and I have 3m squared plus 6m. Since we're subtracting, what we want to do is turn our subtraction sign into a plus sign and then change the signs of the terms in the numerator only in our second fraction. This will help us subtract. So we have a negative 3m squared, so we're going to write him first. And then we have a 4m minus a 6m. So that will become a negative 2m. And then we just have the negative 12 by himself. And that is still over our denominator of m minus 3, m plus 2. And that is our final answer. For number 11, we need to do the same thing. We need common denominators. So I'm going to multiply the first fraction by n plus 5 over n plus 5. And the second fraction I'm going to multiply by n minus 1 over n minus 1. And then I'm going to put everybody in parentheses, so I remember to either distribute or FOIL. Okay, so in the numerator of our first fraction, we want to FOIL together n times 2n, so we have 2n squared. And then n times 7 is 7n. 5 times 2 is 10n. And then plus 35, and that's all over n plus 5 times n minus 1. And then in our second fraction, we want to distribute the 8n. So we have 8n squared. minus 8n. And so now we're ready to combine like terms. Oh, but first we want to change our subtraction sign into a positive and then change the signs of the numerators. So we have 2n squared minus 8n squared, and those are like terms. So if we combine those, we're going to get negative 6n squared. We also have a 7n plus a 10n, which gives us 17n, plus another 8n, which will give us 25n. Then we just have the plus 35 in the back. And that is still all over our denominator of n plus 5 times n minus 1. For number 12, we need to factor first to find what our common denominator can be since we're adding two fractions together. So, the denominator of the first one, I'm going to factor into p plus 7 times p minus 7 since we have difference of squares. And for the second, we need two parentheses. And I need two numbers that multiply to 21 but add to 10. So that would be 3 and 7. So now I need to look at my denominators and multiply each one by whatever factor they're missing. So if I look at the first one, we need to multiply it by a p plus 3 because that's what the second one has that this one doesn't. And in my second fraction, I need to multiply by a p minus 7. And then my common denominator will have all three pieces that it needs. I'm also going to put the p plus 1 and the p minus 1 in parentheses so I remember to FOIL. So if we FOIL the top of the first term, we're going to have p squared plus p plus 3p plus 3 all over our common denominator, which is p plus 3, p plus 7, p minus 7. And then in our second one, we need to FOIL p minus 1 times p minus 7. So that will be p squared minus 7p minus p plus 7. And now we have common denominators, so we're ready to add everybody together and combine like terms. So I have a p squared and a p squared, so that will become 2p squared. I have a p plus 3p, which is 4p. 4p minus 7p is negative 3p, minus another p is negative 4p. And then I have a 3 plus 7, which will become 10. And that is all over p plus 3, p plus 7, p minus 7. Moving on to the solving equations, we see that in number 13 we have one term on each side of the equal sign. So all we need to do is cross multiply in order to solve for u. So I have 4 times u plus 1 equals 7 times u plus 4. So now I just need to distribute the 4. So I have 4u plus 4 equals 7u plus 28. And now I want to subtract the 4u to get all the u's on one side. So I have 4 equals 3u plus 28. I'm going to subtract 28. and I have negative 24 equals 3u. So if I divide both sides by 3, I get negative 8 equals u. In 14, you'll notice that we kind of have some huge polynomials that we're working with. So if we cross multiply, we're going to end up with really big numbers. So what we can do is we can factor the second term and see if we can, if that allows it to be a little bit easier. So if you notice the top, we have 11t plus 121. We could take out an 11 and turn that into t plus 11. And on the bottom, if we factor, we need two numbers that multiply to negative 55 but add to negative 6. So that would be a negative 11 and a positive 5. Now when we cross multiply, we have 11 times t plus 11 times t minus 11. And if we cross multiply the other side, we have t plus 11 times t minus 11 times t plus 5. Notice that we have a t plus 11 and a t minus 11 on both sides of the equation. If that happens, we can cross them out. So all we're left with is 11 equals t plus 5. And then to solve for t, all we need to do is subtract 5. So we have t equals 6. For number 15, we have 3 terms, so we can't cross multiply. So what we need to do instead is multiply by the LCM. To find the LCM, we need to factor x squared minus 2x minus 24. And that factors into x minus 6, x plus 4. So now we have x plus 4, x minus 6, x plus 4. So our LCM, to include all the denominators, is x minus 6 times x plus 4. So that's what we're going to multiply each term by. So now we want to rewrite this as x minus 6 times x plus 4 times 8 over x plus 4 equals x minus 6 times x plus 4 times 5x over x minus 6 times x plus 4 minus 1 times x minus 6 times x plus 4. Now we want to cancel and see what's left over. So the x plus 4's cancel, and we're left with 8 times x minus 6. Here, the x minus 6 and the x plus 4 both cancel, so we're just left with 5x. And then we have minus x minus 6 times x plus 4 because it's just times 1. So now we just need to FOIL and distribute everything. So we have 8x minus 48 equals 5x minus x squared plus 4x minus 6x minus 24, which will eventually simplify into this. Now we want to get everybody over on one side and factor. That will give us x squared plus x minus 72 equals 0. This will factor into x minus 8, x plus 9. So our two solutions, after we set it equal to 0, are x equals negative 9 and x equals 8.